Welcome! We're going to be going over questions 1 through 8 from the January 2016 Common Core Regents. Let's get into it. Question number 1. William is drawing a picture of cross-sections of right circular cones below. Which drawing cannot be a cross-section of his cone? All right, well, first of all, let's just quickly write down the level. This is a level 10 question of 3D shapes. And cross-sections is just the two-dimensional shape that results when you cut a 3D shape. All right, so let's just look at different possibilities here. Now, if you were to take a knife and you were to cut this straight down, right? If we were just to cut this cone straight down like this, what we would get is a triangle, right? So that's the two-dimensional shape that you would get right there. So you would get that, so we can knock out number 2. Now, let's see what else I could say here. Which other ones is it pretty easy to get? Well, if you were to cut it like this, at this angle, what you would end up with is not a circle, but you'd actually end up with an ellipse. That's what this guy's called. Now you're down to 2 options here, and this is where people usually get like, "Whoa, which one is it?" Well, I'll tell you this. If you actually cut it from the corner down, what you would get is a rounded shape, but the bottom would be flat, right? Over here would be flat. So this is actually out, and the only thing you couldn't get here is a square. Come on, where are you going to get a square from? No way. An equation of a line perpendicular to the line represented by the equation y equals -1/2 x minus 5 and passing through 6, -4 is, well, this is from level 7 where we learned coordinate, geo, and I'll just tell you straight up, this problem should be no problem. So this first slope given to you is -1/2, all right? For your line to be perpendicular, your M2 or your second slope has to be the negative reciprocal, which would be +2 over 1, so, and that would be perpendicular slopes. So right off the bat, since you know the questions ask for a perpendicular line, let's cross out 1 and 2. Those are absolutely ridiculous. Now, to actually solve for it, you might remember what we have to do is plug into y equals mx plus b, and whenever we're writing the equation of a line, we write mx and y, m being the new slope that we need, which is 2 over 1, because we want a perpendicular line. We want our points x and y to be 6 and -4, and we're going to plug this in to solve for b. So y, now we just plug in -4, which is our y, is equal to m, which is 2, x, which is 6, plus b. Let's solve this guy out. -4 equals 12 plus b. Subtract 12 from both sides, and we get b is equal to -16. So, which one of these equations has a slope of 2 and a y-intercept of -16? That would be number 4. Now, another way you can do this, just so you know, is you could actually plug the points into your 2 answers. So if you want to do it this way, you could check just by plugging in right here. -4 is equal to 2 times 6 minus 16. -4 is equal to 12 minus 16. And sure enough, 12 minus 16 does give you -4. So you could just try by plugging in the points to see which one is right. 2 different ways to solve this problem. This is easy. Oh man, this question here. It's asking us, what is the measure of WVQ? WVQ is right here. And it's given us some information. It tells us that S is 60 degrees. It tells us that SRT, which is right over here, is 83 degrees, and it tells us that TW is 35 degrees. Now, there's a million ways to do this question. I'm just going to show you one way that I think is pretty good. Okay, so let's get into it. So first, what I'm going to do is try to solve this triangle right here. All right, by filling in the angles that I can. So because of vertical angles, if this is 35, we know we have 35 right here. I know it's hard to see that. Let me maybe zoom in. No, I can't even zoom in. So 35 goes right over there. Now to figure out what this angle over here is that I know consecutive angles are supplementary. So I know these 2 angles have to add up to 180. So if this angle is 60, I know angle R is going to be 120 degrees. The whole angle. Now this part of the angle is 83, right over here. So to get the other part right here, I'll just do 120 minus the 83 is equal to 37 degrees. So let's put a 37 right here. Ooh, it's getting hard to write those in. Now, we can use the triangle sum theorem to find WVR, which is right here. So let's just do 180 minus 35 minus 37, And what that'll give me is, oh man, I gotta do some math in my head right now. That is 72, so it's 108 degrees. So the angle right here is 108. Oh, it's getting hard to fill these in. I'm really gonna try to zoom in. Nope, still not letting me do. Oh, there we go. And then I could use linear pairs to find this angle. If this is 108, I could just do 180 minus 108, and that'll give me 72 degrees. Now, you might have done this a different way. That's fine. I just think that's a really cool way to do it using the properties of parallelograms. All right, people do it all sorts of ways. Yeah, and just so you know, this is from level 5 parallelograms. Let's just draw it out. All right, number 4, a fish tank in the shape of a regular prism has dimensions of 14 inches by 16 inches by 10 inches. The tank contains 1680 cubic inches of water. What percent of the fish tank is empty? Well, first thing we're going to do is figure out how much the total volume of our fish tank is. So this is from level 10, 3D shapes. Now I'm just abbreviating things. And so the volume of a prism, this is a rectangular prism, is base times height. So the volume here is going to be equal to our base, whatever the area of that is. Remember, this is always the area of the base, times the height. Now the height of this is, well, it doesn't really say. It says 14 by 16 by 10. I always just do length with height. All right, so my height is 10, and that means I have a base of 14 by 16. To find the area, I just multiply those together. You should get 224. 224 by 10, well, that would give you 2,240 inches cubed. Now, it tells us what percent of the fish tank is empty. So check this out. What we're going to do is subtract how much it's filled by. So there's 1,680 cubic inches of water in there. So let's subtract those two numbers, minus 1,680. And that tells us that, I'm just going to put this in the calculator. I don't want to make any mistakes on a video. That's embarrassing. So it's 2240 minus 1680, and we get 560, all right, inches cubed. Now to figure out a percentage, all you have to do is part over whole. I'm not sure if you know that, but part over whole, that gives you the percent. So the percent empty is, this is how many empty cubic inches there are over the total amount of cubic inches. So we'll just do 560 divided by 2240, and that gives you 0.25. So to change that into a percentage, you just get 25%. Part over whole is how you get the percentage there. Nice. Now this one says, which transformation will result in a perimeter of a triangle being different from the perimeter of its image? So a transformation happens, and now it has a different perimeter. So what this has to be is, we're looking for something that's not a rigid motion. We want not a rigid motion. Why? Because rigid motions make congruent figures, which means the perimeters would be the same. So let's figure out what each one of these is. We'll label them, and then we'll know what kind of transformation we have. Well, I'll start from the back. This one over here, this is a translation. Remember, if you add something to x and you add something to y, you have a translation. Over here, we actually have a reflection over the x-axis. All right, that's the formula for the reflection over the x-axis, which is also rigid motion. So we'll take those two out. And now we're down to these two guys. Now, you might not know this, but this guy right here, number 1, is also a reflection over y equals x. So since this is also a reflection, that gets knocked out. Number 3, when you are multiplying your coordinates, because you are multiplying, that's actually a scale factor of 4. This is a dilation. And dilation is what we're looking for. That's going to produce a perimeter that is not the same as the pre-image. So the answer is 3. Dilation, baby. Can't multiply those coordinates. And then finally we have number 6. This is a great question. Now this is really hard to say where it's from. You know, we learned about bisect in level 2, so we'll use it there, but this is more of just a thinker question. In the diagram below, FE bisects AC. So this line FE right here bisects AC, meaning it cuts it into 2 congruent parts. And GE bisects BD. So we know GE cuts this into 2 congruent parts, so these two are the same. All right, BC is congruent to CD. All right, so that's the things getting bisected. Now we got to figure out which one's true. Now it's easier if you just think of this in terms of numbers. So let's say AC, this whole thing right here, is 20. If it was bisected, it's 10 and 10. Now, since this is 10 right here, and this also got bisected, we know this has to be 10 as well. Why? If EG is the bisector, well then that means it also cut BD into halves, right? So this also has to be 10 and 10. So this is the same. So, which one of these statements is true? Well, the first one says that AB is congruent to DC, which is actually true. AB is equal to 10 in our example, where we choose our own number, and CD is 10. So the answer here is just number 1. Now, if you look at the rest of these, it says FB is congruent to EB. We don't know that, right? Because we don't know, it didn't tell us that EF got bisected. BD bisects GE at C. Well, we don't know that's true, and we also don't know this one's true. So the answer here was just 1. Try choosing your own number. It might make it a little bit easier. All right, that's it for our first video. 1 through 6 is out. Peace.